Okay, so now we're working with De Moivre's theorem. It's used to find the power of a vector. So if we're working with something, say, square root of 3 plus 1I to the 7th, we're going to recognize that 7 is equal to n. So 7 will replace n here, here, and here. And then we need to find our theta and our r. So to find our r, we'll start in, say, r equals square root of 3 squared plus 1 squared, which gives us square root of 4, r equals 2. Okay, so now we need to find our theta, so we're going to go back to that formula that we had before, which is tan theta equals y. In this case, y is 1 over root 3. We can think of this on our unit circle as being in an unsimplified form, 1/2 over root 3 over 2. I'll show you why right now, because if we multiply root 3 over 2 times 2 over root 3, these cancel and we simplify it to 1. So if we use tan theta as the inverse of, getting ahead of myself, 1/2 over root 3 over 2. Take the tan inverse of that and we find that theta equals pi 6th. Okay, so pi 6 also equals 30 degrees. So if we want to rewrite this, now we'll plug in r, which is 2, and the nth power would be 7 times cosine of 30 degrees times 7 plus I sine 30 degrees times 7, which is n. Put that all together. So there's two ways to do this. We could realize that 2 to the 7th power is 128, and cosine of 210 degrees is going to be, if we're on our unit circle, somewhere over here, right? It's actually equal to 0.876 in our calculator plus I to the negative 0.5 if we plug it in, right? So they're both values are going to be negative, which is why we looked over here and we found, okay, it's in this quadrant, so both x and y are negative. We can multiply it out and that will give us our answer, or we could have used the unit circle to find the radical value here and here and then multiplied by 128, and that would give us our answer as well.